All right, so we're continuing our journey towards a better understanding of the base 12 version of pi by constructing a diagram that generates all 360 degrees using base 12 geometry. So in this video, we're going to continue the process and we're going to go to the fifth ring of the diagram and see if we can go through all the various aspects and qualities of that particular ring in one fell swoop. So we know that we're constructing our diagram in units of 3.2 root 2. The gap between each ring is 3.2 root 2. So we're going to multiply that by 5 for the fifth ring. So 5 times 3.2 root 2 is 13.a root 2. So that's going to be the radius of our first circle, and we draw that. And then we're going to add 0.5 root 2 at a 90-degree angle. That gives us our second lattice point, and we draw another circle. So then when we go down to the x-axis, we can see where those circles are landing. We can calculate the square root versions of these radiuses and then find out their x-coordinates. And we can calculate the gap between these two rings, and we see it's getting very narrow. The next thing that we want to do is look at the degree lines that are already established and going through this pair of rings that we've just drawn. And we can see that again, we can use our red lines that are in sections of 15 degrees. So we twin those degree lines, creating small circles on either side of them. And then we can see that we're also using our blue lines, which are the degree lines that are in 7.6 degree sections. So we draw those circles as well. Then you can see there's going to be a gap formed between the circles that we've drawn. We can find the midpoint between those circles. That establishes our next degree lines, and we can draw those circles. And then we can still find the midpoints between all those circles, generating our next layer of degree sections. And if we want to find out what all those sections are, what are the sections of degrees that we've calculated or created in this particular ring, we can use this formula 26 divided by 18, because in this particular ring 5 times 4 is 18, and we get 1.6. So this particular ring is generating 1.6 degree sections around its circumference. Then if we want to figure out what the interior angle is in each of these small circles, we can use the calculation or the formula n minus 2 times 130 divided by n, where n is the number of sides in this ever larger polygon. So we're on the fifth ring, and each ring is in sections of 24 sides, or 20 in base 12. So 5 times 20 is AO in base 12. So that's the number we plug in for n, and we get an answer of 129 degrees in base 12, which is 177 degrees in base 10. So basically that's it for all the information that's generated with each ring. In the next video, we're going to go over some of the other patterns that are evolving as we travel from ring to ring to ring.